Welcome to Wave-Particle Duality, Cracking the Quantum Paradox. This video will explore the physics revolution that changed our understanding of reality. The world's biggest mystery was whether light and matter behaved as particles with definite positions or as waves that spread through space. The revolutionary answer is, it is both. We begin with Part 01, the classical debate. This was the centuries-long battle between Isaac Newton and Christian Huygens. Newton's corpuscles viewed light as particles. This explained reflection, but failed to explain diffraction, which is the bending of light around corners. Huygens' wave theory proposed light was a wave, which easily explained diffraction. However, it lacked a medium or ether to travel through, hindering its acceptance. In 1801, Thomas Young's experiment showed light creating interference patterns when passed through two slits. This interference victory seemed to prove light was purely a wave. Part 02 covers the crisis, when the wave theory began to face challenges. Planck's discovery showed that energy is exchanged in discrete quanta, rather than being a continuous stream. This concept of energy quantization gave birth to quantum mechanics. Einstein's proof came from the photoelectric effect. He demonstrated that light, hitting a metal plate, acts like a billiard ball, which he called a photon. Light as a particle was cemented by Compton scattering, proving photons carry momentum and collide like physical objects. The result: light is both a particle and a wave. Part 03 introduces de Broglie's groundbreaking idea that matter is also a wave. De Broglie's hypothesis stated that if waves can be particles, then particles, like electrons, must also be waves. Everything has a wavelength, as described by his master equation. Diffraction of matter demonstrated that particles like electrons create interference patterns, just like light. This proved the duality applied to all matter. The Davisson-Germer experiment provided the experimental proof in 1927. They observed the same diffraction patterns for electrons as for X-rays, confirming matter waves. Part 04 explores the mystery, the astonishing discovery that the observer changes reality. If a single electron is fired through two slits, it creates an interference pattern. This implies the electron is in a superposition, simultaneously taking all possible paths. The observation problem highlights that placing a detector to watch the slit makes the wave pattern disappear. The act of measuring causes the wave function to collapse into a particle state. As Richard Feynman famously said, if you think you understand quantum mechanics, you don't understand quantum mechanics. Part 05 discusses the various interpretations, led by key figures like Bohr, Heisenberg, and Born. Niels Bohr's view of complementarity states that the wave and particle natures are mutually exclusive. We can only see one or the other, meaning reality depends on the experimental setup. The Born rule suggests that the wave function is not a physical wave, but a wave of probability, defining the likelihood of finding a particle in a certain location. Heisenberg's uncertainty principle is the fundamental limit on knowledge. The more precisely you know a particle's position, the less precisely you know its momentum, and vice versa. Part 06 explores tech and applications, showing how we are using duality to build the future. Electron microscopy leverages the tiny wavelengths of fast electrons to achieve resolutions 1,000 times greater than light microscopes, allowing us to see atoms. In quantum computing, qubits use superposition to exist in multiple states, enabling exponential data processing, while interference cancels out wrong answers. Quantum tunneling allows matter waves to ghost through energy barriers. This phenomenon is vital for nuclear fusion in the sun and data storage in solid-state drives. The quantum economy is projected to experience sector expansion by 2030, driven by these revolutionary technologies. The revolution continues as scientists explore waves, particles, and the true fabric of reality. In summary, the fundamental duality reveals everything is both wave and particle. Mastering this has led to technological power, from transistors to quantum computing. Thank you for watching this video. Join the quantum revolution by checking out the resources listed here.